Hello and welcome to today's webinar. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The previous webinars from this training series, as well as the webinars from our Industry Solutions series, are all available on our YouTube channels if you missed those. During this presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll email your questions to the presenter for his insights. Today's webinar will be presented by Peter Tainton. Peter has over 20 years of experience in various facets of road design. He's been engaged in large projects for several major councils and government road authorities, and he's worked closely with our programmers in the implementation of a variety of design features within 12D Model, including the superalignment and design speed tables, construction subgrade detailing, design geometry components, overlays, pad design interface, and visualization. Today's presentation, Trimesh BIM Create and Edit Part 2, Advanced, is Episode 6, the final in this series. This webinar will look at advanced creation of everyday survey or design features, so fencing with varying panel definitions, capping and spheres, use of profiles and attributes to define trimesh shape, width and spacing, and 12D objects along a string, and symbol rotation. Please note that the previous webinars from this series aren't required to understand today's presentation, but if you have seen them, you might have a better idea of the context. When I email through the video of this one, I'll make sure that I include links to the previous ones so that you can watch them as a series with ease. Okay, over to you, Peter.
Welcome everyone to our second webinar on Trimesh BIM Objects Create and Edit. So the BIM Trimesh, we select our option. It creates an OpenGL perspective view with the name Preview. For today's session, I'll be using an updated version of the Trimesh BIM panel, Create Edit panel. The updates include the replacement of the buttons by icons. The icons have tooltips as well that match the original button names. We've also added a copy and a paste feature for the vertex segment and also the vertex segment types. The BIM definitions are stored in a standard file called 12D Trimesh node link.4d, which is located in your setups area. We've also added a copy file option, which enables you to copy that file either into your working folder, user, or customer user if you have one defined. The updated version will be in the next release of V14 C2H. As said before, trimesh shapes are applied to strings in your design to vertices and segments, so it's therefore imperative that those strings are valid, no null levels, vertices crossing over or going back on themselves, etc. Attributes play a large role in the trimesh, especially export to IFC. Attributes can come from survey or design strings and project attributes. Attributes can, however, also be set to be used in the creation of Trimesh BIM object, and it is those attributes that we'll focus on today. To enable the process in the short time we have for our webinar, I have created a lot of the definitions prior. So under here I have copied the file with all the ones that are available inside 12D, and under demo I've also created the ones for today. So one for the fencing, motorway and so forth. So we've got quite a few to get through, and it would have taken a bit of time to type those in. And it's just a repeat of the previous webinar in most circumstances. So first of all, we'll have a quick look at the parameters involved in creating panels on a fence that vary in shape, definition and also length, so a mixed variety of two. I'll then also look at capping on posts and placement of spheres. So again, it's a fence we're going to use, which is an ideal structure to show these features off. Again, if we have a look at our demo one and go preview. So we'll just turn off a few of the ones that are already pre-done and just start with the posts. So again, with, under vertex, that's where the posts are. We've got just a simple rectangle, and it's 0.1 by 0.1. It's told to be perpendicular to our design string, and it's got a height of 2 meters. So again, for the capping is made up of, it matches the internal width of the post and has a thickness. So the thickness is applied outside that and also to the top of the post. It also rotates perpendicular to my string. Got a height of 2 meters, which matches the top of the post, and then the 150 mil is the thickness or the height of the capping itself. So preview, and it creates the capping for me. Again, these can also be circles. So again, you could have a diameter for a circular post and a diameter for the capping. So for things like spheres, again, you specify a simple diameter, and in this case we'll specify a height, and height is 2.1. So as we go preview on the sphere, we want it to sit on top of the post. If you wish to have place spheres, one here, one in the middle, one at the top, you could use, instead of running 3 of these with different height values, we could change this to path. And under path here, we could change that to 0, 0, 0, 1, and 0, 2. So we specify those and preview again. So again, if I change this to a circle, drop into here and put a diameter, then preview again, we'd have more of a tubular type fence, and that's how you would create those little nodules or buckle ends. So I can change that back to a rectangle, preview again, and we'll turn off the sphere and keep the capping. Under segments, let's say we just created one. A rectangular vertical was a choice. So the little upright palings are 50 mil square, and they're orange color. Their height 1.8 and they're 0.1 apart spacing. So to combine the different types of panels on the one segment utilizes the extra parameters. So here the extra parameters have I've ticked on start, middle and end, and I want a 0.5 meter for each one of those. I've also come in half of the post width for the start of the actual palings. So when I turn on the other rectangular one and preview that, it is doing the infill. So it's using a rectangular horizontal. It's 1.1 and 1.8 meters high. Set it invert for its justification. And this time under the active, I've got the same parameters, but I've ticked these off, which means that I'm referring to what's left between these 3 half meter ones, what's left in the middle. So all that's controlled by the extra panels. It allows you a fair bit of flexibility in relation to those sorts of features. So a lot of the things that we deal with nowadays are a little bit more complicated. We may also find ourselves with a more detailed structure, like a light pole or some sort of post or whatever it might be. And we may have created the Trimesh inside 12D. We may have also brought in as an OBJ or an FBX from somewhere else, converted to a Trimesh, maybe had to have moved it to Nord origin, factored it, whatever we may have to done to create our block, as for want of a word. So these are all placed using 12DA as a vertex. So in that case here, I've written out a 12DA file of my light. Again, we've done one previously done before, so we'll grab a simple lighting one. We'll go into our vertex, preview. So it's taken that 12DA file and placed it at each vertex on my preview string. Under properties, it's told to rotate this 12DA file perpendicular to my design string. So I may also want to be able to create another one called lighting symbol. It looks very much the same, but under properties, it's going to rotate to a symbol rather than perpendicular to the string. So it means that when I look at my row design and my design here, I've drawn a string that represents a point string that represents my position of my my lights, and I've also placed symbols on them at odd rotations. So if I go under BIM Trimesh, again I can pick up that string I've drawn with all the points on it. I can drop down to my lighting, and I have a model for that. So I don't need to worry about any interval distance. I want to use the actual points on the string. I go process. So it creates the lights for me. So they're all perpendicular to that string that I drew. If I then want to change that to the one that rotates to the symbol, process, the lights all then adjust, so they're facing back ways, different angles in relation to these symbols. So it just allows you that flexibility. So anything for intersections and so forth that you draw strings with symbols, you can match a 12DA file to those. The main part of the webinar today is to look at the creation of Trimesh definitions using profiles. So we did look at some of the profiles in the previous webinar, but we selected those and saved off the definition. This way in the webinar today, we're going to save them off the 12DA file, similar to the light. We'll first look at a feature bridge, which has a variety of standard and more detailed features. So again, the strings or shapes are drawn at 0, 0. 0, 0 will be the reference string in your final design, which is this point here. So on my string, I have a decking drawn. On the left-hand side, I have some shapes that represent the top rail, bottom rail, and middle rail. I also have a shape that represents a large major post, and a shape that represents some smaller battens or palings in between. On the other side, we have another a little bit more detailed shape. So that shape is the outer post. It has used the hole feature in 12D to create a hollow in the shape with a thickness applied. There's also another shape drawn that represents a web or a gusset plate in that post, which is a little bit thinner. And there's also some circles drawn that represent some bars. And down the bottom there's a base plate for that large post. So some of those shapes, like the decking unit and the top rail and bottom rail and so forth of that fence, are just to be run the full length of the applied string. But the other shapes, the uprights, the posts, the bars and so forth, they need to be specified as a width and an interval down your design string. You're able to do that via the attribute information. So under Utilities Attributes, Global Attributes, you select the option called Trimesh Profile and Shape Placement. This has already been done before, obviously to speed things up. So we can use a single picker option here, which allows you to pick one of the shapes and it'll return the attributes that have been applied to that previously. So that shape there is going to be a post, and it's going to start at the start of my string. It's going to have a width of 100 mil and be spaced every 2 meters along that string. The ones in between, a little bit closer together, they're going to start 150 mil away, they're 45 mil wide, and they're going to be 60 mil spacing. Again, over the other side here, the same sort of thing. If I set that, I've got some attributes for the larger post and also for the webbing in between, or the gusset in between. So again, things like the decking unit and these posts here have no attributes attached to them at all. To give you an idea of what that means, is this is a section of my bridge. So here's my decking unit. So in the real world, this will be the start of my design string. So for the larger post, on the right hand side, I want to come in 100 mil from the start of my string. It's going to be 200 wide, and it's going to be 2 meter interval or spacing between that post and the next one. The same would go for the base plate, but for this webbing in between, right, it starts 180 mil in from the start of your string. It's 40 mil wide, and the distance between the internal distance between there and the other plate is 2.16 meters. So when they all sit together, they will match each other. So that's how those attributes are set. Obviously not all are set, only to the ones that you wish to apply a width and interval to. So go to our preview, and again we're looking at our feature bridge that looks like that. So we've written out a 12DA file of this shape, like we did with the street light. There are some other things attached to that profile on the same model. There's a magenta string that represents a headstock and some orange strings that represent piles. These are only for context, just to give you an idea of what the bridge looks like. They're not going to be used in the creation of this bridge profile up here. They're going to be done in some other process. But there may be something that you want to add to the 12DA for 12DA file, just give you a bit of a picture. It could be dimensions added to it. There could be some notes. It could be just to give you that QA idea. Excuse me. So in order to do that, you don't want them to be used as part of the Trimesh creation. Anything that you have like that, you can give the name info only. So if you name things with that particular name, they will show up on the 12DA file if you read it in, but they will not be used in the creation of the feature. So write out a 12DA file of that, and again we go up and create our shape, and we drop down and we grab our feature bridge. Again, we'll just turn those off and just look at the main feature part at the moment. So I go preview. Again, it's a bridge. So I'm going to look at something maybe 40 meters long and not a fence. We'll change that to 1. Preview. So that's created our shape for us from our simple profile down our string. So our previous string at the moment only has a vertex here and there. So these are actually intervals worked out along the string itself, not in relation to vertices. So again, it's just a simple 12DA profile under here, like similar to what we did with the vertex. Under segment, you pick 12DA profiles, and you go to our file and grab our feature bridge. This is defined in our working folder, but it also could be in your user library or customer library area. So under here, I'm looking at the headstock and piles. So I could look at a rectangular headstock, and I may be looking at being able to create that in relation to the width of my walkway. So I'm going to use the path option. So the path option will be minus 1.5 and 1.9 and minus 0.6. So that means it's going to sit here. So if I get set on that, and finish, and I go preview. So that means it's going to put that shape in here, so it's going to go from a coordinate there of minus 1.9, minus 0.6, and 1.9 and minus 0.6. So it's using that path to apply the shape of my rectangle. Again, you need to have a look under properties and rotate that in relation to this string here, so it needs to be perpendicular to that string. To do our excuse me, to do our pile, again it's just a simple diameter. It's got a height, so it's below this string, so its height is this height here, so it's minus 2 meters, and it's also 900 mils down from there to sit underneath the bottom of the headstock. So again, it's using the height and the offset horizontal and vertical to push it down into its position. I'll also turn on that one, and it creates the other one, which has a horizontal offset of 1 meter this way. All three have to come in from the end of the string, so they're all using the extra buttons similar to the segment panels that we did on the fence. So these are going to come in at the start and the end of the string by 300 millimeters to align with the end of the deck. Again, while that was created, I was able to then utilize those 3 tri-meshes, because this is 0.0 in relation to my profile. I was able to output those as a 12DA file. So then I can come in and create an abutment start, which only has a 12DA file, not those 3. So I go preview, I still get the same result as I had before, but I can then mix and match them. I can have a one for the start, picking up that 12DA file. I can also have one at the end of the structure, preview, and this is for the end of the string. So in that case there, I've rotated 180 degrees to get the shape that applies to the end of it. So I was able to use something in the creator to create a tri-mesh and then output that as a 12DA file, then reuse it back in as a different definition. So that gives me a simple profile, quite a complicated one, but only from a simple profile drawings and applying a couple of attributes. So again, for bridge tiles, we can then look at the same profile idea for a motorway. So again, same process. We've drawn a shape. 0.0 is going to be our reference alignment string. We've got definitions in relation to pavement, curb, some barriers, island, medium barriers, even got a light profile. So if I pick on those, they're just simple shapes, light. There's a shape in here that represents the barrier. There's also another little shape that's hollow, or that isn't closed, which is the metal part of the barrier for the light. You've got a curve and channel. So it's also got a point. So if you draw your profile and you create a point string, or just a simple point on the end of that, and call it interface left, when the profile is run, it will not only create a tri-mesh, but it'll also create a string, a super string on the outside here. You can also do the same on the right hand side. Just call that interface right. It will create a string for you. So that string you can then use to attach interface, decisional templates, and so forth of your concept tri-mesh that you're going to create. Again, all the information about the intervals, similar to this bridge here, has been applied through the attributes. So we've got information about our shape of our light, our barrier, where they start, how wide they are, how often do we want them. For the row profile, for the tri-mesh, obviously no attributes applied to those. Things like the dimensions and notes and so forth you may put on, again, are QA type things, so they have the name info only. So again, I write that out as a 12DA file, so I can then drop down and select from my demo my motorway, and under segment it's picking up a simple 12DA, a preview, and that creates my file for me. So again, similar to the small bridge, it's just utilizing those attributes in order to create shapes or widths to the profiles you've drawn. Obviously, this light here is not as detailed as the previous light, but still gives you an indication of what it's going to look like. So also for the row profile, there's also a bridge profile drawn. Same idea. Some things have attributes attached to them. These things here, the plate and the little support for the rail, but the decking units and so forth like that, and this one here would have no attributes attached. I've even done the line marking here, and they have attributes attached if need be, if they're lane lines, that to mimic a normal lane line, 3 meter, 9 meter gap. So again, write out a 12DA file of that. Go off here and grab motorway bridge and preview. So you get the same idea. So you've got that simple shape, and then the attributes are then creating the interval and width that you need for any particular shape at all. So again, for our tunnel, same thing. Drawn a profile, 0.0 for my design string. Some things on the top, lights, have given attribute information. Things like our cable conduits, our support brackets would have attribute information attached to it, but the main structure would have none. So I drop into here and I grab motorway tunnel, and again preview. So it gives you a good idea to be able to create a quick concept process of a complicated tunnel by 12DA profile. Just one simple definition will give you that particular detail. So I'll look at my design. So if we get rid of our light and our lighting, we'll go to where our tunnel's sitting. So inside my design, I've got I've run a MTF file along my road centre line, and all it's in here is it's just creating the road, the strings in the centre that I can then apply my shapes to. No major design. That's what the shape is doing that for you. It's doing that concept idea rather than having to create multiple entries in your MTF file and creating shapes in there. So I set up an alias for my tunnel, an alias for the extent of my bridge. I've just inserted at the center with 00 a string for the road, a string for the tunnel, and a string for the bridge, and given them an appropriate name. They all sit on a model called Design RS201 strings. So to apply that, I go into my BIM, Trimesh, and apply. Similar to what we used in the start of our series of webinars. Again, we've already saved some of this information to save time for us. So we'll drop down to the road one and go read. So it's using the filter option, finding everything on our design model whose name is road. So I go filter select. It's picking up the profile and motorway, and I go process. So it creates my definition of my road. All the things that I showed in the preview have now been applied to a real world string. So again, similarly, I can grab the tunnel, read that in. It's picking up all strings that have the name tunnel. So I go filter select, picked up my definition. My segment type is tunnel, and I want every 10 meters for this definition. So depending on how long the tunnel string is, whether or not you can play with that regular interval. So again, if I zoom in here, we now have our profile for our road and our tunnel. So if I go to my bridge feature, again, we do the same process. As you can appreciate, I've already filled out some of these for us. Read that in. It's picked up everything that's a bridge from my design model and applied the bridge profile to it. So that's the ability of being able to run these things and be able to link them to your alignment string, having that parametric design ability, come back, alter your job, move your alignment string, and then just simply rerun your concept profile. So again, under my aliases here, I can go to my bridge extents, and I can say, look, I want to make the bridge a little bit longer, so I'm going to go back from the start, and I'm going to go forward from the end of the bridge. I reapply so that updates the string that I created in my design MTF file, and I go back and then I run my bridge. So I go filter select again and process. So the bridge is now longer than what it needs to be, than the road. So I now go back into my road profile, read that in, filter select, process, and then readjust the road to suit the new bridge. So again, shifting your alignment string, updating just some simple strings that run down the center of the road. You haven't got a complete design here. You've just got some road center lines and a profile. So I go back to my feature bridge. Again, there's also a design string in there, offset away from my center line, just the one string. So I go to my feature bridge, read that in, pick up my walkway string, and I go process. So this one here is a little bit different because it had the headstocks and stuff available as well. So not only I used a 5-meter interval for the length of the string, which were the distances I used for the headstocks here. So under there I placed one at the third vertex, the fifth, and the eighth. So basically it's producing the position of those headstocks. So again, that allows you that sort of flexibility, all from the creation of just one string. And again, the ones on the outside here of the road do have that superstring with that name, so you can attach interface details to that string as well. So not only from that simple profile you've drawn and a MTF file with just one string down the center of the road, you're able to create something at this scale. You can obviously get areas and information volumes from the trimeshes with that interface string on the edge that I showed you. You can attach a interface, a decisional templates for your final batter. You can create a tin from the bottom of the trimesh that was on that profile definition that I drew, and once you've got that tin from there, you can obviously then create a super tin and get volumes and information about your future design. So hope that gives you a fair idea of what you can do, especially with just by drawing simple profiles and creating those shapes. I'd like to thank you very much, and hopefully you can attend any other webinars that we may have.
Thank you, Peter. The recording of today's webinar will be available in coming days through the webinars page on our website and our 12D Model YouTube channel. Keep an eye on our emails and social media for details of future webinars. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.